Hello, everyone. Welcome to my webinar, Three Common Kubernetes Growing Pains and How to Solve Them. My name is Dmitry Shevrin. I'm going to present today for about 45 minutes. That's the whole idea. I'm going to talk for about 30 minutes into three subjects of how Kubernetes pains can affect our lives, and then we'll leave 15 minutes for questions. So let's start. I'm Dmitry Shevrin. Like I said, I'm a senior solution architect for Spectro Cloud. Previously, I worked for SUSE and Red Hat, and I've been doing infrastructure part for many years now. So counting maybe 15 years. So in the last 5 years, I've been specializing in Kubernetes, and from time to time, I talk in different conferences. So there are a couple of slides of me. But let's get to why we're actually here. So Kubernetes has been everywhere, and if you've seen it, it's in the clouds, it's on premises, in the edge, it's everywhere, right? So the deployments the number of deployments has been quite high, and it's a complex system. It's an open source system. It's an open source solution available for pretty much everyone, but it's not that simple. So if you launch a deployment of Kubernetes, there are quite high chances that you're not alone if you're facing any problems. So it's not that easy. It's more or less easy to start one cluster, but as soon as you're growing your estate, you will find more problems, right? So when you manage a reasonably decent estate of Kubernetes cluster, you become less efficient if you are spending your time on battling Kubernetes issues, right? So issues which are related directly to Kubernetes. Now, if you don't solve these pains in time, then you're limiting yourself in growth. That means that you invest your precious time into solving some mundane tasks, and this is not great, right? So you can't do something creative, and you spend too much time onto routine tasks without spending it efficiently. So how would you know that you are experiencing pain in Kubernetes, right? If you catch yourself on a moment that you spend a lot of time debugging some sort of Kubernetes intrinsics, like maybe services, I don't know, stateful sets, daemon sets, ingresses, if you're looking to make Kubernetes work, and then just spend this time onto Kubernetes itself, this is at this point you will see pain, right? So at this point you're doing job for the sake of the job, right? So Kubernetes is supposed to make you faster, so to allow you to deploy applications, manage your containers efficiently. It's not always the case. So what I gathered from my experience working with various customers across the world and in different industries, there are three main pains. The first one is that you would want your developers to be efficient, right? So the chances are quite high that you're not playing with Kubernetes for the sake of it. You are eventually running some applications of it. And surely enough, you're running some basic applications, maybe Kubernetes, CNI, CSI, to make it work. But then you're running some sort of your applications, so applications which are bringing your business value. So something which was created internally or something which was adapted internally. Now, it was created, but guess what? Now, sometimes you need to modify code. You need to push some changes. And this can be very difficult and time consuming for your developers to push code changes to applications which are running on Kubernetes. Second one is multi-cluster headaches. So it's easy to manage if you're all together, or relatively easy to manage if you're all complete in one cloud. So let's say you're 100% on Amazon or Azure or Google or Tencent, anywhere. But we are seeing that whenever you have to manage at least two cloud providers, and that may not necessarily be cloud. So it may be one of them can be your old legacy data center and another one may be cloud, right? So this is already two different environments. When you have to coordinate Kubernetes in between these two environments, then that creates you a headache. That creates you complexities on how to standardize. Well, given, guess what? The CSI, let's say in vSphere and CSI in Google Cloud behave or may behave differently. So it's now up to you to synchronize how you want this behavior to be synchronized so that you would offer an experience more or less identical between two platforms. And the third pain is edge. So, right, we'll talk about edge a little bit more. What is it? Why we are specifying it as something specific, as something different from standard data center deployments. But these are the three three pains that I more or less collected and resume it as something that I can see quite often and that can be eliminated, and therefore you can improve your professional life. So let's concentrate on developer first, right? Developers, what do we do? We write code. Okay, so code, well, it's there, needs to be written and then tested and then verified, right? So it's like a modern system. Quite often assumes not only one developer writing code, but one developer writing, second maybe doing some sort of pair programming, or some rules, the company rules can be applied to the code. So this code will need to be verified. Today we talk more and more about shifting left, so it needs to be verified for security vulnerabilities, so it needs to be verified for syntax and correct style. And this is all long process, right? Now, normally you would be running some tests against code or against the binary file that is compiled from this code. So you need to look something how to test that the code that has been written is actually correct code, that it corresponds, that it solves a problem, that it improves the situation. Okay. Now, some of the changes which developers we are making, they're quite tiny, right? So they're minor. Sometimes you just need to change one value. Sometimes you need to change one if cycle. So you need to change something simple, right? You don't want to launch the full-blown rebuilds of verifying against checks. But guess what? Sometimes it is necessary. So therefore, when you're under a condition that you want to change or to make a small minor change, and then you want to verify that the change has indeed solved your problem, you may be in need of creating a Kubernetes cluster, or maybe you need on reinstallation some software. You may reuse clusters, it is possible, but then you'd have to solve the problem of remnants. So how are you making sure that if you're changing something, that all the ingress configuration, that all the bits are not, that the PV are not there. So you'd have to, it is doable, but it also takes time, right? Now, one of the conversations I heard, there was a feedback so that the folks would have to wait for a couple of hours, even for changes such as changing the background color, right? So that's literally a couple of bytes to change. But still, because of all this complexity around the CI/CD pipeline, that would that was incredibly time consuming. And guess what? Multiply the number of challenges you are seeing by this complexity and necessity to wait, and then developer efficiency goes down, right? So CI/CD. If you work with developers, the chances are you have to organize CI/CD pipeline so that they would be able to work efficiently. Modern CI/CD pipeline are not easy. So that whatever you want to launch, there will be, like I said, security checks. There will be some verifications. There will be some deployment rules. Someone doesn't work to do deployment in parallel. So in real life, you would always have some sort of complexities when you're organizing CI/CD. When you add Kubernetes to this mixture, stuff becomes much more difficult just because, well, you need to simulate somewhere, right? So sometimes maybe a developer wants to write code on their laptop. That's also not quite easy how to do so, given that eventual the result of this code is going to be run onto a production Kubernetes cluster. That becomes a complexity. So number of developers. Let's talk about how we collaborate, right? So if you're just alone writing a hello world application, you don't really need any complexities. You don't really need any ecosystem around it, right? So you only need to have something that can work right away. But when you need to collaborate, well, guess what? Sometimes the different teams would require different Kubernetes versions. Sometimes you'd want to play on your cluster. Now, if you want to develop locally, that is tempting to use your laptop, but in order for you to write code that would be correspondent that you'll be able to use in the future, you need to simulate the whole production system, and that can be difficult, right, due to various factors. So what we are doing to help in here, we are leveraging virtual clusters. Virtual cluster is an open source project available out there in internet. Just go look for and search for it, and we make it enterprise ready so that developers will be able to create their own clusters. Now, let me clarify what do I mean. If you want to build something, if you want to modify, if you want to test your PR, if you want to test your commit, you can, as a developer, have your own cluster quite quickly. And when I say quite quickly, I literally mean tenfold. So let's imagine you want to create a new cluster on any cluster platform, Google, Amazon, Azure. It will most probably take you a double-digit number of minutes. It can be 10, 20, 30, depending, I don't know, on the speed, on how complex your cluster is. But it's still that won't be 3 or 5, just because this is experience from what I got from cloud platform. Even the most simple clusters are not that quick let alone HA versions and deployments of some Helm charts on them. So you can't regularly create normal clusters quickly, just because this is how cloud providers work. But with virtual clusters, you can, right? So you can create them pretty much everywhere on any public cloud. You can still benefit from all the Kubernetes magic inside virtual clusters, but you can offer them for free to your developers, right? So your developers can create their own clusters. You can even create a mechanism of requesting a cluster. This is what we offer from our interface, but the idea stays the same independently of whether what you use. For developers, it's quite convenient to use virtual clusters. Okay. So let's go to the second one. Kubernetes estate and multi-clusters. Now, like I briefly mentioned, it is relatively straightforward when you're all blown on one cloud provider, independently of which one you use. And we try to stay agnostic. We try not to recommend one or another cloud provider. But what we are seeing across the market, across various countries and verticals, is that the number of clusters increases, right? So once you go there, eventually your number of clusters will inevitably grow. So it depends on many factors, well, given the macroeconomic conditions or your personal IT projects or budgets. The speed of growth can be different in your specific circumstances, but most probably it's going to be growth. So it may be a really exponential growth, or it may be a slightly slower growth, but it will still be growth. That means that with time, we will only have more clusters. So normally how it starts, you create the first one, you may be created manually, you've created kubectl commands, you've sketched a kubeadm, you use something like a K9S solution, doesn't really matter. So you play to something, you create one cluster. Then at some point you would separate production and development. Then at some point you would help some other teams, and therefore you have a lot of clusters, right? So it's a gradual growth, but we expect the growth to happen in double digit soon, right? Also, when you in today's security world, you are required to isolate applications. And yes, it is possible to isolate applications using namespaces, of course. But guess what? If you manage to obtain and to a privilege escalation, you can still overcome this limitation by namespace. So that's not a guarantee. That's a good first step to separate applications into their different namespaces, different independent namespaces. But in reality, you still need to have a better isolation if you want to be secure. As you see, there are applications which are migrating to Kubernetes, right? So like I said in the beginning, most probably you're not just doing Kubernetes for the sake of it. You are running some applications. And if it's easier to write at the beginning applications that were created specifically for Kubernetes, let's say something standard that people run, I don't know, Prometheus, Grafana, all this stuff. But then eventually your legacy applications, either they're going to be transformed or they're going to be in some way migrated to Kubernetes. And what we are seeing is more and more developers do work with Kubernetes. That explains this growth, right? So you may expect this growth to continue. Now, how this applies to you exactly? Like I said, it's easy to create a first cluster manually. You don't really need to have any solution, right? But at some point, you are splitting the solution, and then before you know it, so Kubernetes world lives quite quickly. So in 3-6 months, everything changes. So if you start deploying something today, chances are in next year your number of clusters will be in double digits. So it's because if you're efficient, if you're creating Kubernetes clusters, if you're helping, then there is demand for it, right? And like I mentioned before, for developers, there is a desire to use something for yourself. So if you can afford having a Kubernetes cluster, well, it makes sense to have it. Now, there are various solutions out there. So if you only want to modify a number of clusters, if you only want to manage them, you can find a plethora of solutions on internet. Most of them will probably be open source. So you can go there, you can just use kubectl, K9S. There is nothing wrong with it. These are good solutions. But guess what? The infrastructure has evolved a lot in the last 10, 15 years, all right? So while it's still possible to install clusters, install servers, and just connect by SSH to them and not to use any configuration language tools such as Ansible, Terraform, Puppet Chef, whatever have you, Salt, It is still possible, but in reality, because you as a specialist or you as a IT manager are responsible for the growing and growing number of clusters and servers and networks, it just becomes less efficient, right? So you can't just be efficient by modifying and being taking responsibility and managing everything manually. So most probably, in order to stay relevant on this market, in order to be efficient as an IT department, in order to be efficient as an IT specialist, you need to be using some sort of modern tool set, right? So we thought if you're applying infrastructure as code principles to servers, why not apply them to Kubernetes as well, right? So within our company, what do offer as a solution, and then principle stays the same, but the solution can be anything. We offer specifically here Palette, but these principles, how to manage multi-cluster panes, will still stay the same, right? So the idea is here that you don't need to be making, or you need to really minimize your manual configuration changes, right? So you should declare how you want your infrastructure to look like, and then you need to launch the correspondent deployment using infrastructure as code. Now, it's up to you to decide which solution you want to use and which solution is the best in your circumstances, but you should really minimize the manual intervention, right? Now, we've seen on a number of occasions that if you're going specifically on one cloud, that may backfire on you later, okay? So I would suggest if you have the luxury of constructing an IT solution, go cloud agnostic. So just try to create constructions that will not depend on any one specific vendor. Otherwise, you're just risking vendor lock-in and it's hard to overcome. Now, one single pane of glass helps immensely because that allows you to oversee as a human being everything that is going right or wrong. And technically speaking, it's not necessary, but guess what? In my experience, it really helps you to grasp at once everything which is happening. And when you look at this screen, maybe once a day or with some frequency, that allows you to understand right away what's going wrong. Now, if you followed landscape of Kubernetes, you know there is a lot of various mechanisms over there. And I'd say you can achieve all of these points, or the first 3 points, using Cluster API. Cluster API seems to be today a more or less standard solution across the community. Now, Kubernetes changes a lot, so that may change. But as it looks today, the Cluster API is quite convenient approach. So if you've never heard of it, I encourage you just to go there and read about it. It's open source. It's an open source tooling. We extend Cluster API within Spectro Cloud, so we extend it to application levels. But independently of what we do, Cluster API is something that I'd encourage you to take a look and to use in your day-to-day opportunities. Now, within Spectro Cloud, we sketched a solution which is called Palette, which is working out there today. And what I'm showing you today is just some screenshot. So these screenshots showing UI of the solution. You can see that we can compatible with various clouds. So in the clouds, we do Amazon Azure, Google Cloud, Tencent, and we do data center deployments on vSphere, on OpenStack, on Canonical Mass. We can do edge deployments. So this is the solution that is following the recommendations, so you can deploy using the same set of principles your Kubernetes clusters everywhere, and you can modify them, right? You can modify, you can patch them, you can upgrade them. So this is more or less how the solution is going to look like. So that's our profiles, which we use a declarative model, right? So we use declarative model to declare how you want your clusters to look like, and then we apply them in an agnostic way across the whole set of clusters, the set of platforms. Okay, so your clusters can be running on any clouds. Your clusters can be running on premises. Your clusters can be running on the edge, and you have the opportunity to manage them, to launch clusters and to kill them, to upgrade Kubernetes without service interruption. If they're an HA, you can deploy Helm charts and pucks onto these applications, so you have the full control over all clusters. All right. So these are the principles I recommend you apply to multi-cluster deployments, and this is one as an example. I'm showing you our solution that is being used today by a number of customers across various verticals and countries across the world. All right. So that's just an example of how we apply these principles. All right. So when we have edge, let's talk about edge, right? So what is it? What we call edge? First of all, that's from deployment standpoint is very similar to data center deployment, right? So there will be some devices, maybe x86, maybe ARM-based. you would need to install some operating system on them. So we assume that some devices come empty, maybe from the factory. Um, these devices should be serving obviously some purpose, so they should run some applications. And quite often, and more often than not, we are seeing that there is a necessity to run Kubernetes on the edge. Now, what's the difference, right? There is a number of differences. So if you start to deploy edge, like real deployments, at first you may think that, well, guess what? I take my Raspberry Pi, I take my Intel NUC, I take my NVIDIA Jetson Nano, doesn't really matter. I install my operating system, I launch Kubernetes with kubectl, that's it. You can do everything manually without any solution, probably within an hour or a couple of hours. So yeah, that can be the case. Except that in reality, there is a huge number of challenges that come specifically with edge, right? So what are we talking about? Well, let's put it that way. The edge is a number of small devices. So the first difference between data center and edge would be so that we have a habit now that in data center deployments, most of the servers are quite powerful. They can be HP, Dell, I don't know, whatever have you. It's like, but they're still powerful. There will maybe Intel Xeon processors, and maybe there will be a number of hard drive, reliable hard drive on SSD or whatever you run. The memory is going to go into double-digit gigabytes. So these are relatively powerful beasts. So maybe 1 unit, 2 unit doesn't really matter, but still they're quite powerful, as if compared with Intel NUCs or Raspberry Pi or small devices, right? Second, edge is something that is far away from the data center. So if you are talking about data center, that most probably we are talking about reasonable internet connectivity, such as fiber or anything reliable. May still be a DSL somewhere, but still it's relatively reliable. When we talk about edge, this is something which is going to be maybe running on Wi-Fi or maybe running on 4G. Sometimes there may be power cuts, so that's difficult, right? So and third, the number of these solutions is going to be high. So we are talking about tens of thousands of these locations, right? So there may be some sort of chains, I don't know, restaurant, grocery stores, anything like that. There may be fabric installation. So there may be a number of deployments. So these three differences, the power, the network connectivity, and number of devices, present a unique set of challenges, right? So you can't really reuse the very same approaches you use in data centers in order to build edge configuration, right? And this unique set of challenges requires specific solutions, all right? So what I'm talking here is that we need to apply a specific set of solutions so that you can be efficient in not only managing edge and Kubernetes on the edge, but also managing Kubernetes in the same way like you manage it on premises or in data center, so that you'd be able to keep the single point of class, single point of management across your whole Kubernetes clusters. So what I offer you here is that we need to be defining how to use cluster deployments in profiles or anything similar. So you need to still be declaring it, right? So you need to define somewhere how you exactly which software with which versions is going to be installed onto the edge devices, and you need to keep it somewhere in a GitOps model. Now, this needs to be a full-blown solution, because guess what? If the location is quite far away and you have to install something onto it, the chances are there won't be any Kubernetes specialist, there won't be any IT guy there. So it needs to work out of the box just by plugging in a USB stick. So you need to be able to install the whole operating system and Kubernetes so that your device can call home and say, hi, I'm here, and you'd be able to manage it from some point. But this needs to happen automatically, right? Now, the recommendation which we learned the hard way is that it needs to be immutable. All right, so that's because of the same set of problems. There is a chance that it can be removed, it can be rebooted unexpectedly. Guess what? Power cut, or someone can just touch the cable and therefore have a power cut on the device. So that means that device needs to be as simple as it can. So when I say device, I mean both operating system and as much as we can with Kubernetes, right? So that's why we do these 2 points: immutable OS and low touch onboarding or no touch onboarding. That means that someone can just plug in USB, Ethernet, and power, and that's it. So there won't be any requests, login, SSH, IP, all this magic, just because the personnel on the ground won't have skills to do it. So you need to be able to manage these devices from some central point of location, some central location point. The last point in here, A/B rolling updates, is important when you're not deploying HA cluster across your whole estate. All right. So that means that you only have one device, and if something has gone wrong during the upgrade, you still need to be able to get back to the device. Because if we are talking about devices that have that if we are talking about infrastructure with a high number of devices, and something goes wrong, you don't really have an opportunity to send a specialist each time the device has disappeared, right? Imagine you have a number of thousands, I don't know, 10,000 devices, and someone needs to push an update. So yes, you can sketch it. You can split it into a number of updates. Maybe are tens of servers, or hundreds, or thousands, or maybe not thousands, but tens or hundreds or dozens. But still, there will be a number of servers, right, in a chunk. So what you'll be able to do is to schedule the update of this chunk by chunk. But still, if something has gone wrong, you still need to fix one chunk that has gone wrong. And you can't most probably afford sending a specialist to physically reboot the server and to do some plug, some sort of disk magic. No, that is not doable, right? So you need to be able to roll back efficiently. So A/B partitioning helps here immensely. Now, these are the principles I described. So what I'm showing you here is an application now, is an application of the principles in our solution, which is called Palette. So that, as I said, Palette manages Edge in the same way it can manage on-premises deployment or in the cloud. And it's efficient. It's out there. It's available on spectrocloud.com. If you go there, you can create an account and play with it. But this is something similar as you would see. You'd be able to define which modules exactly you install on your edge devices. You can modify them. So we try to abstract and offer infrastructure folks an opportunity to not to suffer through Kubernetes and to remove this pain of edge and multi-cluster. So you would have a graphical interface that is easy to understand. So you don't have to have a massive Kubernetes knowledge. But at the same time, we are not hiding anything, right? So if you need to modify something, if you need to modify some sort of challenges, it's still doable. You can go there. You see right now, I'm sharing on my screen to the right, there is an option to modify some sort of YAML code. So if you know what you're doing, yeah, it's absolutely, why not? All right. So what do I want you to take out of my talk, right? First of all, yeah, if you are suffering with something, most probably you're not alone. Just because, well, guess what? Kubernetes is hard. If you go to landscape.cncf.io, you'll see there is a number of applications. So find your way to which application to use, how to do that. It is difficult, right? So just don't stress about that. Second, will be a number of solutions, right? So there is a number of problems, but there is also a number of solutions. If you search for solutions today, you will find a lot of various solutions which solve various problems. Okay, so that's just out there. So the most efficient thing you can do is to try and oversee a number of solutions and pick which solution brings you the most value. It brings a solution that brings you that fixes problem that takes you time, right? That take time from you. Don't do it yourself in the sense that don't reinvent the wheel, right? So you can pretty much solve all of the problems with some bash scripts with kubectl. Yes, it is doable. You can do so even today. You can just write everything yourself. But this solution is not sustainable, right? So there are folks there specializing in deploying IT, so benefit from others, right? Just don't try to create everything from scratch. We've seen that that's doable. It's taking a lot of resources and therefore may not be the most interesting thing to do. Okay, and last but not least, don't forget about day two operations. So what I mean here is that we've seen quite often that for deployments, there is a lot of resources invested into planning. So how the architecture is going to look like, how the deployment is going to look like. As soon as you've deployed your Kubernetes cluster, as soon as you exposed over ingress some service and you've seen hello world, you think, perfect, that's it, that's now working. Well, yeah, kind of, except that there is still a number of day two operations. And what I mean by day two operations is something that connects this first hello world experience up to real world production deployment, where you need to have monitoring, where you need to have login, you need to have backups, right? So all of these things you can easily ignore and just still prove something works. Well, it does work, except that in the long run you will still need to solve all these problems. Otherwise, you may be in a fragile position, or you may suffer from these points of day two. So have a think, and where you're deploying something, invest some time or leave yourself some time into the configuration of day two operations. So that would be my recommendations. If you can just benefit from what we already learned, I think it could just make your life a little bit easier. So I think that's everything more or less I wanted to tell you. So if you have any questions, I would appreciate. I'm not sure, Janki, if you have any questions here, have anything, I'm happy to answer. We still have 15 minutes. So.
Yes, we do have some questions that have come in. So one of the questions is, why not just use open source versions of virtual clusters to simplify the developer experience? What would your answer be to that?
You can. So the thing is, like Kubernetes, vCluster is open source. So you can do absolutely and use open source virtual cluster, but you will still spend time on adopting it to your needs, right? Because most probably you're just not want to launch in one cluster. You need to organize it, you need to play with it, you need to apply your own set of Helm charts or applications or binary files. So you can, but this is going to be time consuming. So like with Kubernetes, right? It's also an open source solution. Therefore, if you're using some solution allowing you to embed vCluster in your own infrastructure, you can just be more efficient altogether.
Okay, great, thank you. Can you run vClusters on any infrastructure or only on this on some specific clouds?
You can write it, you can run it everywhere. So that's the beauty of the solution, right? So if you are preparing a deployment of vClusters, this is going to work in an identical way. So this is what I was mostly talking about here, is that these virtual clusters allow you to apply the same set of principles across various clouds. So if you want to launch it on premises or in the cloud, that's doable, right? So you can create an identical experience for your developers working with vClusters independently where the host cluster is running. You can even run them on the edge if you really want to. So it depends if you want to do it, but most probably your use case is going to be in between on premises and in the cloud. And to answer the question, yes, it can run on any solution and any infrastructure provider.
Great. Another question has just come in. We're perfectly happy with our own cloud provider. Why would we want to do multi-cloud? What would your answer be?
Well, yeah. So if you're happy with one provider, that's it's difficult to kind of to push you to have another, right? So maybe a couple of reasons. So what I've seen. First, either you want to be more you want to increase your reliability, so you want your solution overall infrastructure to be not to be subject to problems within one cloud provider, but also what I've seen is that because of business decisions, let's say because of merger and acquisition, one company can acquire yours, or your company can acquire another company. So at some point, you as responsible for IT person, you will be responsible of merging this infrastructure. So you may decide this on your own just to increase resiliency, but more often than not, it's coming from a business side. So you are now in front of a fact that you have to merge two infrastructure of two different companies. And at this point, guess what? It's not convenient. It's not efficient to reproduce everything that you're saying. If you're happy with one provider, that's fine. But you've probably invested some time into preparation, into the tool set, and building the tool set, and adjusting the tool set. So what I'm saying here is that if you at some point are faced with the deployment of a second cloud provider, most probably you have to find some solution, maybe a pilot.
Cool. Another one here. Why would we want to install Kubernetes on the edge? Is it not easier just to run containers?
It is easier to run containers, right? So there may be two reasons here. So first of all, if you are in a luxury when you can run one container onto the edge device and just stick to it and never run any second or third container, most probably you won't need Kubernetes. But that's not something I'm seeing in real life, because even though if your application is only one container, at some point you'd want to monitor it. At some point you want to log or redirect loads or write them somewhere or offload them somewhere. At some point you'd want to take backups. So if you're under specific circumstances when you are only running one container and you're confident there will never be in your life any other second container, most probably you won't need to have Kubernetes. But that's not something I'm seeing. So as soon as you will start, and bear in mind, if you start the deployment with one container and then you would want to add a second one once the solution has already been deployed, it can be a difficult situation. You can just shoot yourself in the foot a year from now when you will need to run the second container. So in order to summarize, if you can if you anticipate that you'll be running and at least two, 3 containers, then Kubernetes can become more efficient. Another reason for running Kubernetes is that if you're going to run some applications, there is a chance that these applications are already delivered in help format. So whether you want it or not, you need to run it. So hope that answers the question.
Thank you, Dimitri. One more that's just come in now. We've sketched our own solution for Edge multi-cloud based on Terraform. Why should we consider Palette?
It's it's a good question. I hear it from time to time, and it's like it's always difficult to convince someone that the solution is not good, right? So it's like if you've written something, if you've deployed something, if you I don't know if you're working with a solution and it's answering your needs, then it's difficult to change it. But what you should think of, whether you'd still be well, first whether it's going your internal solution that you sketched, whether it's going to work in the future with a growing number of clusters, with a growing number of challenges. Would you still be happy to support it? Would you still be happy to develop it? What happens if those who created the core of the solution leave the company? So it feels like it depends on which industry you're talking. But so if for big IT companies with big IT departments, I can see how this can work. But with verticals such as that are not specialized in IT, if you're a small team of a single digit number of people, yeah, 5 7 people, so if you've deployed some solution, if you've written some solution, are you confident that this solution is going to live with you for a long time? So to bear in mind that technologies change all the time. Bear in mind that you need to patch it, you need to incorporate new stuff. At some point, you maybe need to include service mesh. At some point, you need to include backups. So all that requires time. If you're at a luxury position when you can afford all this time, it may be a very valid scenario. However, many with whom I spoke don't really have this capacity, especially going in the future, to support constantly and to invest time into solutions of such sort. So therefore, using some specialized solution, for example, Palette, can become a quick win so that you don't invest your time, you don't reinvent the wheel. You just trust those who specialize.
Amazing. Thank you, Dimitri. And I
Pleasure.
think that's it from the questions.
Okay. So I think we still have a couple of minutes. Maybe then but couple of slides I wanted to show is just a going forward links. So this is where I would encourage you to read through some of the links as to how to maybe look at the specific webinar our team ran about virtual clusters or read about cluster API. So these can be useful stuff independently of what you do and which solutions you use or don't use, but just to follow some of these solutions. So if you can just either go on the link or just scan a QR code now, these can be two valid resources. Obviously, I can watch it for free. And specifically about Edge and reports, so that's can be something useful as well. So I think we're doing a lot on the Edge now. Today, it's very lively segment. We do offer our solution to manage clusters and deploy them efficiently with applications. We do write our own operating system, which we open source, or should I say, meta operating system, which allows you to use. So there is a lot of there is a lot of things going on. So yeah, there are a couple more links in here. So I think at this point I'm pretty much done. So if there is no more question, I can just leave you my LinkedIn in case you want to get in touch. And yeah, that's it.
Thank you very much, Dimitri.
Pleasure. All right.